So good afternoon. You might wonder why an art college has been linked to a grand challenge and safety at sea and risk. So what I'm going to do is help solve that question, and I'm first going to start by describing a little bit of our background, which you can see here. So in 1837 we were set up as the Government School of Design. So back in the heart of the Industrial Revolution, the government realised actually that we have this problem. And the problem is the interface between technology and society. And that's the role of design, is actually to somehow make a smooth transition between the technologies we develop and how those are kind of implemented and used by society. And then a little bit later on, this kind of wonderful gentleman, Prince Albert, helped to instigate the Great Exhibition of 1851. And he used the proceeds of that to build this, Albertopolis. So if you get your Google Maps open and you look at this part of London just south of Hyde Park, you can see something called Albertopolis, the city of Albert. So the proceeds from the 1851 exhibition helped to found all these institutions. So Royal School of Mining, Imperial College, Royal College of Art, the Royal Albert Hall, Science Museum, Natural History Museum, the V&A, they were all kind of founded in this one moment of time. And the idea was that we should all collaborate. So the idea was to share knowledge between the arts, sciences, humanities, and use this for the greater value of the country. And we ignored this for about 150 years. We dived into our disciplines, we ignored our neighbours, we became experts at ever increasingly narrow kind of subject areas. But luckily, over the last kind of 10 or 15 years, we've started to turn the tide, and we've built a number of collaborative courses, collaborative research, and other activities that are starting to draw this kind of knowledge back together. So today, Royal College of Art has about 1,900 students. This makes us the biggest postgraduate art and design college in the world, and also makes us the smallest postgraduate art and design college in the world, because we're the only one that actually teaches postgraduate art and design to students. And we're also the smallest university in the country, so we're sort of quite bespoke in this kind of sense. You might think it's a school full of artists, kind of people painting and making sculptures and various other kind of aesthetic activities, but actually 70% are designers or people in the kind of what you might call applied arts areas. And here you can see the courses in the School of Design, which I represent, so these are all the kind of courses in blue. And about 30 years ago, these were all basically forms of industrial design, so we grew out of industrial design. And this is a kind of very kind of rapidly moving area which is fostering these new disciplines like service design, experience design, interaction design, and so on and so forth. And we've just launched a healthcare design course this year. We also have a vast amount of cultural diversity. So this is one example. This is the Innovation Design Engineering Dual Masters. It has 40 students per year and some PhDs, so about 110 people overall. The balance is roughly 50-50 male-female, which for any course with engineering in its title is kind of quite a major achievement. Students come from 27 countries and around 17 different disciplines. And you can see by the list that we're going through: architecture, chemistry, biotechnology, we've got furniture design, graphic design, material science, mechatronics. We've even had a world-class quantum physicist join our course. And what we do is we help these students work in groups. So it's really about kind of facilitating interdisciplinary, cross-cultural learning. And what that does for our environment is it breeds variety. So if you want great innovators, you need more variety. You need more cultures, you need more disciplines, and you need to cross-fertilize and kind of curate this creative ecosystem. So this is what some of our graduates go on to do, a bit more tangible stuff. You can see that the London bus was designed by Thomas Heatherwick, who was a graduate from the RCA the year after me, so he designed the London bus. We've got James Dyson, who's our provost, who's revolutionised the vacuum cleaner, which is quite interesting because the vacuum cleaner had been around for 100 years, so you wouldn't really think that somebody could come up with a new idea and revolutionise this market and capture the lion's share of the market in such a short space of time. So it still shows that even with kind of very heavily developed products, there's still great innovation opportunities. Ian McCallum and the new Jaguar, and we've had lots of students go to and work for Apple. So 3/4 of Apple's Futures group comes from the Royal College of Art. Okay. We also have a big focus on interdisciplinarity, as I've mentioned. So these are some of the partners that we've worked with over the years. We worked with the BBC on the future of the remote control. We worked with Ford on interior vehicle innovations. We've worked with Hudson Whampoa on the best possible mobile phone ever. We've worked with Samsung on developing innovative materials and how they could be applied to new products in 10 years' time. So lots of work kind of fusing different kind of designers and lots of kind of industrial challenges that are also at the heart of our institution. So this is some of our research. We redesigned the London ambulance about 4 years ago. So this was very much involved in user-centered design. So this is where we go and work with ambulance technicians and paramedics. We look at the entire process, and then we kind of redesign from the ground upwards. So the innovations here is that the patient treatment trolley is in the center of the ambulance. So that allows the two technicians to work around the casualty as they're being treated, rather than working on one side. It also optimizes all the different medical equipment and medical supplies that they'll be using to treat that person. So it means we get more treatment faster, more flexibility, and we can think through all the routines and all the different kind of processes that are being used. We even painted the hands of the technicians with an ultraviolet dye and got them to go through several of their treatment regimes to see what they were touching and get an understanding of the different kind of bacteria and also where contamination could be on the equipment. And that allowed us to kind of choose surfaces and design features that would minimize contamination. Sticking with wheels, this has been covered a few times already today and yesterday. So we're part of a consortium looking at putting driverless cars on the Greenwich Peninsula. And our piece of work is looking at the interface between cars and pedestrians. So one of the interesting things that's going to happen here is people are going to realize pretty fast that the cars are going to try really hard to stop and not run them over. So that might mean that people are actually jumping out in front of the cars, more kind of Pokemon Go incidents. Maybe people pushing their buggies out in front of cars. And so suddenly we might have this very disruptive influence where the average speed of transport in London might actually get lower. It might actually slow the whole transport system down. So this is one of the kind of potential psychological impacts of putting driverless cars onto our city streets. Another impact is we might see more drinking. You can go to the pub, have your 10 pints of beer or your 10 glasses of wine, jump in the back of the car, get driven home. You haven't broken any laws. So there's potentially negative social consequences there. We also think that car manufacturers might code their vehicles in relation to their brand expectations. So you might find a BMW next to you is always first off the lights, and the Mercedes SUV is always tailgating you 10 centimeters the whole way home. Whereas the Renault is kind of placidly driving down the road, you know, and behaving properly. But these different type of coding models might collide. So there's some really fascinating kind of research to be done in this space between technology and society. And design is kind of one of the useful tools that we can use to understand the user-centered aspects of this. In the year 2030, there's not enough metal on the face of the planet to continue making aircraft at the rate that we're making today. So one of the big challenges is how we completely reinvent the aircraft production process. So we're invited by Airbus to start looking at this scenario and to look at how we could design a bird bone fuselage that would be woven and rapid prototyped all as one kind of single component. So we did some finite element analysis, applied a Voronoi algorithm, and then designed a full-size aircraft fuselage. But we also designed a whole cabin interior. So we were looking at the whole loading process for getting people's baggage into the plane. Maybe the hand luggage goes in separately. So kind of lots of innovations around that. Also potentially allowing each passenger to have a different level of visibility outside the plane. So if you're a very confident flyer, you could have an almost transparent fuselage and just see the world going by. If you're a very nervous traveller, then maybe there's a much more kind of minimized view of what was kind of happening outside. We've also worked with NASA and Thales, Alenia, and ESA. This is working on a Mars rover. And we were looking at the whole ConOps, the concept of operation, from launch to the payload deployment, to living on Mars for 6 months. But our focus was actually on the human being. So this is a kind of human-centered aspect. Whereas if you look at some of the other agencies, NASA's model is an optimization model. So the human being is optimized alongside the payload, the weight, the cost, and everything else. And usually the psychological parts are quite hard to optimize. So they tend to get ignored. So one of the big challenges, as was discussed yesterday, is how to get somebody to Mars in a sane state of mind. How can we get somebody there who's actually psychologically and physically in a fit state to take advantage of the kind of opportunities once they arrive and get back to planet Earth in good conditions? So those are some of the aspects that design are actually quite good at tackling. This is one of our student projects. Duncan came to us and said, I want to reinvent the wheel, which is, it's kind of a bit worrying. Wheels have been around for thousands of years. And what he actually ends up doing is originally designing a folding bicycle wheel. And that was then funded by our incubator, and he eventually developed this towards wheelchairs. So this is now a folding wheelchair wheel, and it allows the whole wheelchair itself to fold up small enough to go into the overhead lock of an aircraft cabin. So suddenly we have great mobility. Disabled people can get onto an aircraft. They don't have to wait to the back of the queue or have those very difficult kind of situations of waiting for the wheelchair to come out of the hold and being kept waiting and so on and so forth. So actually it's a very small, very simple, very easy thing to think about. Just make a folding wheel. But the engineering and the technology and the dedication to deliver this project is where the real effort is. This took 5 years. 5 years from graduating just to make a folding wheel. And you'd imagine after having wheels for thousands of years that we should be a little bit better at understanding the potentials of this idea. We did some work for the London Paralympics. So this is a trainer for a Paralympic athlete. And one of the problems for Paralympic athletes is having enough coaches. So there's a lack of coaches. So this is for a javelin thrower. And what this allows the person to do is record their perfect javelin throw with the coach, and then have audio feedback as they're training. So they can train on their own, and the audio feedback then allows them to figure out their arm positions, power, length of throw, and so on. So this is, again, quite a nice innovation around Paralympics. And then kind of slightly coming a bit closer towards our grand challenge, we took a group of students to Australia to work on sports innovations, and we worked with the Surf Lifesavers in Sydney. And this project was looking at people drowning in the coastal waters. One of the big problems in Australia is that the cities are quite far apart, and it's hard to get emergency services or aid to people on remote beaches or beaches that are further away from the city centre. So the aim here is that we'd have a tower on each beach, and then we'd have remotely flown drones that could fly out and drop in front of the swimmer and give them some temporary flotation aid until some better kind of services arrive to support them. Another project we worked on was looking at visualizing rip currents. So the idea here is that you anchor this onto the shore, and then it's kind of partly education and also partly warning. So it shows people visually where the rip current actually is in the sea. So people who don't understand about kind of seaside living, ocean environments often get into trouble in riptide. So this again is trying to visualize and using design as a kind of education, but also as a preventative measure. So finally, our grand challenge, ship-to-ship transfers. So we're looking at the risks and the safety issues when people move from one form of ocean vehicle to another. So when they move from one ship to another, or from a jetty or a quay or a dockside onto a ship, and the large amounts of incidents that happen around this. It affects basically two groups of people. So it affects kinds of crew, surveyors, ship's pilots, rescue authorities, RNLI. They all have these kind of issues. And also, obviously, for civilians, recreation, cruises, and kind of public transport. And what I'm going to do is take you through one example. So we're going to be looking at ship's pilots. So this is kind of a slightly more extreme version of transferring from ship to ship. So this is the activity, climbing from a small ship onto a very large ship. Sometimes pilots might have to go up as much as 9 meters, and sometimes in very stormy environments. Now, what the pilot does, I'm sure most of you probably know this, the pilot boards the ship and then helps guide that ship into the port, avoiding reefs, avoiding kind of cliffs, avoiding other kind of unseen issues, navigating currents and so on. And then the pilots also help the ship to leave the port until it gets to a part of the ocean where it's safe enough to disembark. If the weather's rough, the pilot might want to leave early. Or if the weather's rough, the pilot might not be able to get onto the ship until a point where it's already potentially going to ground and cause huge kind of safety issues, potentially large amounts of pollution and loss of life. So this is actually, even though it sounds like a simple activity, getting off a boat, climbing up a ladder, the implications and the knock-on effects can be huge and kind of quite catastrophic. So Southampton alone has about 10,000 transfers per year. So that's something like 100,000 transfers over 10 years. And they reckon they have about one accident, one serious instance every 10 years. South Korea reports 200 to 300 transfers per day. But we think there's a large amount of underreporting of incidents. We can't find data yet that gives us a kind of global picture of how many people have incidents, what kind of industries they're in, what kind of scenarios actually produce the highest amount of casualties or potentially even loss of life. And we found there isn't much of a feedback loop from port to port. So a ship's pilot might report that a particular ladder is dangerous or incorrectly rigged. That information will get sent to the next port. But there's no loop then that comes back to say whether that's actually been addressed, whether it's been fixed, and to know that these problems are being solved as ships move around the world. There's obviously a wide variety of different types of equipment. So in some parts of the world, people are craned on using a kind of winch system. In other parts of the world, people climb a ladder. Some parts of the world, there's also helicopters, which have their advantages, but also have the disadvantages. So what I'm going to show you next is a little bit of film that hopefully works that's going to show you a transfer incident. Now, if you look at the pilot boat captain, you know, he's still trying to get to the back of the ship, to the back of his boat to find a flotation aid. And by the time he's thrown it, the poor victim is quite a distance away. So there you go, it happens very, very quickly, and this was just one slip on one step. And you tend to think that this incident happens in, you know, it might happen in a port or harbour the other side of the world, or in a kind of a different part of the country. But it happened in London last week. A pilot fell off a ship, or there's an incident, and was killed in London, 6th of October. So this happens in the middle of this city. These incidents are common, and people's lives are lost. So the question here is, what can design-led innovation offer? What can design do in this kind of space? The things we can do is we can work with stakeholders, we can work with users, so we can really get to the heart of the problem. And we analyse the entire activity, so this isn't just when the pilot might touch a ladder and climb to the top, and that's it. We might look at what he's eating for breakfast, or we might look at how he drives to the port. We look at the entire activity and look at all the factors that might affect this kind of activity. So really try and get under the whole kind of process and the whole lifespan of how pilots work and how they transfer on and off ships. We'll also look at combining physical and psychological insight. So this isn't just about physical stuff. It isn't about making a better ladder. It's not necessarily about making a ladder that's less slippery or that shows when it's worn. It's about the whole kind of set of conditions. If a pilot gets onto a ship when it's very stormy, they feel much more vulnerable, they feel more at risk, so it changes their mindset, it changes the way their body moves. So design tackles both those areas. It tackles the psychological aspects, but also the physical aspects. So the project structure for us is we have 5 researchers and tutors working on the project for 3 months. We then have a 1-week solid idea generation and immersion process. And then we have 3 months the students working part-time alongside the tutors, designing, working with stakeholders, going on to site visits, seeing pilot transfers. We've organised with the RNLI in Poole to rig a pilot ladder transfer in that immersion pool. So our students will climb up the ladder and then fall off safely. And then we'll show them how to kind of get on board a kind of survival vessel. So the aim here is that the designers actually experience the activity for themselves. They can actually personally, physically and psychologically understand the mindsets of the people that they're working for and try and get as close to that situation as possible. We're going to design and build prototypes, test rigs and simulations, and then we're going to exhibit these in early 2017. So expected outputs. At one end of the scale, it's going to be looking at the traditional existing transfer arrangements. So we might be looking at ladders. We might be looking at what happens before somebody gets on a ladder, during the incident, post-incident, training, recuperation, but also totally different ways of getting people on and off board ships. This activity is 300 years old, so it's ripe for innovation, it's ripe for revolution. We can think of different ways of getting people onto a ship. It was fantastic seeing one of the talks yesterday about the gecko gloves. Amazing. Maybe that's the way to get on. Gecko gloves, stick to the side of the ship, climb your way up, and maybe there's an amazing graphene slide to kind of shoot you down once you've done your stuff on board ship. So I think also we'll be looking at possibly the psychological aspects and also training and potentially standards as well. We built a great set of partners from the RNLI, Marine Accident Investigation Board, Associated British Ports, the Port of London, the Royal Navy, and the Marine Pilots Association. So all these different agencies and institutions are willing to work with us and give us their expertise to help us on this fantastic safety challenge. Okay, so that's my little presentation over with, and if you'd like to ask some questions, maybe, that'd be great.
Well, I think we've probably got time for one question.
Thanks very much, Simon Reeve, Lloyd's Register. Quite often in these challenging conundrums, taking the human out of the equation completely has to be part of the solution ultimately, accepting there might be some other sort of short-term solutions. Is that something you're also considering?
We did talk to the Marine Pilots Association about this, and they believe that it's obviously at some point possible to create a technology which could guide a ship into port without the necessity of a pilot. But their counter-argument is that the kind of psychological value of having a trusted local pilot might outweigh that technology. So they still feel that the kind of human aspect is really important. And when somebody sails from the other side of the world into your port, they want to feel that there's a local person who knows the local sort of currents and the local conditions who can help that ship arrive safely.
Good. Thanks very much.
Okay.
Great. Thank you.